So imagine you are inside a building. Inside a building is full of white walls, is full of reflective surfaces. You cannot extract any feature from a white wall. This is why photogrammetry also works very well for drone photos, because when you fly a drone over a construction site, in each photo you see many, many features because you see the ground, you see all the... So there is no issue with feature extraction with drone photos. But this is why photogrammetry works really well for drone photos. It doesn't work really well with indoor photos because indoor is full of white walls or, unique colors. It's very difficult to extract features. So then you need an active sensor, and this is a laser scan.
So we have a really exciting episode for you today. Dominique Pouliquen, CEO of Cintoo, a cloud-based platform that turns heavy laser scanning data into shareable browser-ready files. In our conversation, Dominique traces his path from pioneering photogrammetry in the late 90s to compressing terabytes of point cloud data today, then breaks down everything you need to know about digitizing existing buildings. Hey everyone, thanks for listening to another episode of Buildings 2.0. Today I have the pleasure of speaking with Dominique Pouliquen, CEO of Cintoo, reality data platform. Dominique, thanks for joining me today.
No, a pleasure. Thank you, Joseph, for inviting me.
So before you were the CEO of Cintoo, at the forefront of reality capture, for the last 25 years, you've become obsessed with capture, accuracy, deep research, and bringing it to market. Take us all the way back. I mean, why buildings in the first place? And how did you even get involved with reality capture?
Yeah, this is a long story, but it started many years ago. I always have been in computer graphics, 3D computer graphics. I worked first for a French aircraft manufacturer called Dassault. They were building 3D simulator, beautiful 3D stuff, and then worked for a post-production company, a TV company called Canal Plus. I've been always excited by creating 3D data, and at some point I had a chance once to meet a very clever guy, a very research scientist from a lab. He was developing a technology that we now call photogrammetry, but which is about, let me take a series of 2D pictures and I will create a 3D model out of that. Oh my God, that was a fantastic idea. And, how can you create a 3D more easily by taking the world as is as a reference, okay? So instead of building a completely new model of, a truck or whatever, I would take pictures of an actual truck and I would create a 3D model out of that. That was a fantastic idea. So together with these research scientists who have developed this technology, we created the first company called RealViz. That was in 1998, so probably you were not even born at that time. But anyway, on that company, I was a CEO of one of the co-founder and CEO for 10 years. And we were the first photogrammetry engine to really productize this really cool, what we call bundle adjustment or, photogrammetry technology. It was so cool. We applied that to many different businesses, including special effects. But now we found that the most interesting business was around, architecture and design. Okay. And then we got interest from Autodesk at that time for this technology. And then we sold the company to Autodesk in 2008. So that was my first exit as an entrepreneur. And then I became an Autodesk employee and we created a computer vision lab here in France. And then they asked me to go to the US in San Francisco at the headquarters to start a new group called Recap. And I was one of the co-founders of the product name Autodesk Recap, which is all about point cloud, technology. And this is where I enter the world of laser scanning. Okay. And Recap has been a fantastic journey. I spent fantastic time in San Francisco at Autodesk. And after a few years, I had a chance to meet older PhDs, older scientists from another French lab that was trying to sell their technology to me as a Recap, a guy, and say, okay, now, because the challenge we had with Recap at that time was say, this point cloud is so massive that they sit on disk on your desk, okay, and nobody can really share or consume this data since it's completely desktop centric, okay. And these other scientists came to me and say, we have a cool compression technology that will take your point cloud, make it much lighter, And then this is, oh wow, this is what we need now to expand the point cloud business, is compress the data, making the point cloud compatible, and then becoming shareable, collaborative, and things like that. So we started Cintoo at the time with this core technology coming from another lab. And this is what I like to do, take these cool core, technologies. These are mostly mathematics, developed by PhDs, and make them actual products that are being used and sold to end user. This is how that has been my passion for the last 25 years and still is.
I don't underestimate the journey that you have gone through. You just casually dropped your journey from photogrammetry to LiDAR point clouds to now meshes in one fell swoop. For those that don't understand why this technology matters, for say the non-technical real estate professional, why does this technology matter?
Yeah, no, this is a good question. People have been using laser scanning or laser scanners for 50 years. Okay, this is not a new technology. Why do you use laser scanning? Is because you want to create a virtual copy of your as-built conditions. For example, in the architecture industry, 60% of the business in the US is for renovations, or maybe even more than 60%. But anyway, I don't know the final numbers. And in many cases, you need to know your as-built conditions before starting a new design. So this process of getting a laser point cloud, and making it a BIM model on which you can apply your new design is called scan to BIM. This has been around for 20 years, 50 years. No, not 50 years, 15 to 20 years. And this is exactly why people would use laser scanning in the architecture industry. You laser scan an existing building because you want to make a 3D model out of it, a BIM model out of it. And from this BIM model, then you can start building your new design, adding your MEP stuff, adding your new layout, adding everything you need. And so this is why laser scanning is so important for the architecture industry. The difficulty, and this is what we have been solving with Cintoo at the beginning, when we created the company in 2017, 2018, this point cloud that you get from those laser scans are really massive data. Okay, laser scanning is, imagine a device on a tripod that will collect between 10 million points and 160 million points per vantage point. We creates about 2 gigabytes of data per vantage point. And since you need to place this tripod in many places, you end up with terabytes of data. This is why we needed this compression technology to make this point cloud data cloud compatible. And then once it's in the cloud and you can view that in a browser, then you can share it and collaborate with all kind of stakeholders. You can send that to your electricians, you can send that to your MEP engineer, to your whoever has to do something. You can do any measurement, you can do any annotation. So you're virtually immersed in the actual building without any need to visit the place physically. Does it make sense what
Yeah.
I'm saying?
It does. And so what, if I'm understanding correctly, on the one hand, we have the technology to accurately digitize, convert from a physical stuff, brick and mortar, into digital
Yeah.
files. The challenge is most of the time those files are very heavy, making
Yeah.
it very hard or difficult, mostly for non-technical folks to see
Yeah.
that.
Yeah.
What you're highlighting is that developing a technology that then makes those very heavy files compressed and just much, much easier to digest.
Yeah.
What needs to continue to be true in the technology to make it easier and easier and easier for, again, today we're talking laser scanning professionals and architects, but I'm always interested, like, how do we get this technology in the hands of non-technical real estate professional? I mean, what
Yeah.
needs to be true in order for this to continue to democratize?
Oh, I think this is coming because what we have seen I've seen that in the last 10 years. 10 years ago, in order to get a point cloud of your facility or your building, you will need to spend probably $150,000 to buy one equipment. Okay, it will be a Leica scanner, it will be a Faro scanner, it will be a Trimble scanner, whatever. but that would be the amount of money you would need to buy an equipment 10 years ago. Now you have got much cheaper devices, like talking about 10K, still expensive though, but and also you have got not only laser scans on a tripod, but you also have on a backpack. These are mobile scanners. So scanning is becoming much easier to do, easier to use. When you scan on you walk around, you see on your tablet the point cloud being created. So the whole user experience around scanning is much, much simpler, and it's getting simpler every year. And the devices are getting, cheaper and cheaper as well. So this is a trend. Of course, there are other technologies. For example, Matterport. Matterport was introduced like 15 years ago. And they were using this Kinect device by Microsoft. The Kinect device was this device invented by Microsoft that you would put on your TV screen that will capture your motion during a video games. And they kind of use this technology to scan a place, They put it on a tripod as well, and they will be able to scan the place around. But this is a different technology. This is not laser scanning. This is a projected light. And there is a limit in distance, like 3-5 meters. This is using infrared lighting, so you cannot use it outdoor and things like that. But they started a real good business in this area of real estate, because these devices using this Kinect device from Microsoft was sold for less than 2K or even less than 1K now, okay? They really democratize access to reality capture, but with limited range. Now they added the Matterport Pro 3, which now also has an active sensor like a laser scanner. They have a laser scanning. So and you can buy a Matterport Pro 3 for what? 2-3K now? I don't know the price exactly, but you see, so all these technologies are being democratized a lot.
Yeah.
Okay, and it's still going on. If you take a company like XGrid, this is a Chinese company. They introduced their new device like maybe 1 year ago. This is a handheld device, and you can buy it for less than 10K. Okay, so it's coming.
How do you, for those that might not be too familiar with the nuances of photogrammetry, LiDAR, meshes, we have emerging formats like Gaussian splats and others. How do you kind of bucket these different technologies and understand the pros, the cons of each?
Oh yeah, this is very, let's compare first photogrammetry with laser scanning. Photogrammetry is a purely passive technology. So you take pictures, 2D pictures with a digital camera or a drone, and you take overlapping pictures, and the whole photogrammetry process is also called bundle adjustment. Is based on the fact that in those photos you will find matching features. So you say this feature on this picture is the same as this feature on the next picture, etc., etc. This is how, with a bundle adjustment algorithm, you will be able to define then your camera information.
That underlying technology, is that based off like image recognition? So in other words,
Yes.
recognizing an object here and then an object.
No, not objects, just features.
Features.
You know that, for example, the corner of this smartphone seen from this photo is the same corner from the same smartphone from this photo. I don't know this is a smartphone. I just see a 2D pattern.
Right.
You see? The point is that photogrammetry works well when you have features to extract from the photos. So imagine you are inside a building. Inside a building is full of white walls, is full of reflective surfaces. You cannot extract any feature from a white wall. This is why photogrammetry also works very well for drone photos, because when you fly a drone over a construction site, in each photo you see many, many features, because you see the ground, you see all the... So There is no issue with feature extraction with drone photos. But this is why photogrammetry works really well for drone photos. It doesn't work really well with indoor photos, because indoor is full of white walls or, unique colors. It's very difficult to extract features.
Right.
So then you need an active sensor, and this is a laser scanner. A laser scanner with this laser beam, with the reflection of the laser beam, will give you a deterministic XYZ location for each or one of the laser beam. You see, I insist on one point is determinism. With photogrammetry indoor, you are never sure to get a good result. So it's not deterministic. With a laser scanner, you are sure to get a good result at a few millimeter accuracy. So it's very deterministic. So this is why people use laser scanning indoor much, much more than photogrammetry. You see?
And then to take it one step further, meshes. How can I place meshes in context of?
Okay, so then both technologies will extract point cloud, okay? Because with photogrammetry, those features that you extracted will become a 3D point at some point by triangulation, you know? So the type of data you extract from photogrammetry and the type of data you extract from a laser scanner is still a point cloud. But a point cloud is not an actual representation of the world. The world is not made of dots. The world is made of surfaces, okay? So at some point, you want to turn this point cloud into 3D surfaces. And this is exactly what we do with Cintoo, and we do it in a clever way, okay? And so that what you see finally in your browser, when you get the data in your browser from the cloud, is not a dot, is not a set of dots. And the dots also have this particularities that you see through the dots, okay? So when you do, for example, a measurement in Revit with a point cloud, you are never sure that you pick the right point or the point which is behind, because this is, you know, there are a lot of holes in this point cloud, you see? When you use surfaces or 3D meshes, you don't have holes. It's a surface, okay? And so the world is not made of dots. The world is made of surfaces. This is why people love to use meshes. And the meshes is a kind of, you know, a polygonal structure that you get in a video game as well, okay? So people are used to navigating 3D meshes, basically.
Right.
More than point cloud.
Right. You know, the term digital twin is something not new. We've been talking about this for some time. And I've noticed, depending on who you ask, there's also a different definition as to what is a digital twin. If you ask folks in the kind of photogrammetry space, they often refer to what, you know, perhaps a dollhouse would be a digital twin. If you ask folks in kind of the BIM space, they'll say, you know, BIM is digital twin. How do you demystify digital twins, and are we kind of missing the point? Like, how can we get a better, more refined definition, and ultimately why it matters?
Okay. No, I see. For me, a static 3D model, like a BIM model, a CAD model, a dollhouse, these are static CAD models, okay? So I would call that 3D models, or say BIM models or CAD models. The difference between this static 3D model on a digital twin is that the digital twin is supposed to be connected to the outside world. So it's a living 3D model, okay? Otherwise, you don't call it a digital twin. You just call it a 3D model, okay? Even a dollhouse is a 3D model or a CAD model, okay? So the difference between a CAD model, a BIM model, or a dollhouse and a digital twin is that the digital twin is connected to the outside world, like with sensor data, okay, with all kind of documentation. You click on something and then you get the documentation. So you enrich your model, your CAD model, with much more information, eventually feeding this model with live sensor information. This is the difference. So again, model is static, digital twin is dynamic and connected. And then now we are adding another concept between those two. I don't have three hands, but if I had a third hand, I would put it here, which is called the metaverse. And the metaverse, for me, is an extension of a digital twin, which adds human in the loop, okay? When you need to have people inside, you need to interact, you need to simulate like a car, truck driving or whatever. Then you take your digital twin, you add human in the loop, and you add 3D simulation, you enter the metaverse world. Again, starting from a static CAD model, enriching that with live sensor information and making it dynamic is a digital twin. Adding human in the loop is a metaverse. This is my definition of those three concepts. Does it make sense?
For those wondering, the promise of that metaverse extension, it was so talked about even just a few years ago that a company like Facebook completely changed their name to Meta, with the promise that they're investing billions of dollars to bring this to light. Now, that hasn't necessarily panned out, at least not at a level of scale that I think was promised. What ingredients, what is missing to invite the masses into metaverse? Like what are we still missing?
I never was a believer in the social aspect of the metaverse, to be honest. Okay, so the way that Meta or Mark Zuckerberg was trying to sell it, okay, we will meet in those 3D virtual spaces, and then this is a metaverse. Come on, every demo that was done at this 3, 4 years ago was very poor quality, very low quality 3D space. It looked like a video game 15 years ago. Come on, we can do better. And what is the need to be immersed with a headset to meet your friends?
Right.
Already you meet them like we do today. You are in New York, I am in Sofia Antipolis, and we have a good experience. Do you need to have a 3D? I'm not sure. I'm not convinced. Okay. So the social aspect of the metaverse, I was never a big believer. What we see now is the industrial metaverse really picking up, and this is what we're really interested in, because industrial metaverse is all these applications, all these use cases when you need to bring your existing factories, refineries, complex site in a virtual space to interact and collaborate in a multi-user experience for actual, industrial use cases, which are from training, simulation, clearance, checking, all kind of stuff. Okay. And this is a big, big move. So thank you, Meta, for setting the word metaverse. But we're not interested by the social media aspect of it. Okay. We're interested by the industrial metaverse applications. And there are many.
Yeah. So what you're suggesting is that perhaps we jump the gun a little bit in that the promise of more of a consumer or like meeting and more of a social aspect actually skipped a step, where you're
Yeah.
suggesting that actually some of the more tangible, perhaps practical
Yeah.
use cases start
Yeah.
in when you say industry, we're referring to physical spaces in which production happens. And
Absolutely. Or it can be a building being built. The social aspect is also still there. We call it a multi-user experience because you would use your metaverse
yeah,
to collaborate or meet other stakeholders at the same time, at the same place, virtual same place, although those guys are completely distributed over the planet, So this is still, but it's for an industrial purpose. Okay, not to chat with your girlfriend, doesn't make any sense to me.
yeah. I mean, show me the future. Like, so let's 5 years from now, I am a Fortune 500 company and we produce bottled cans or cars. What does the facility look like? What is the digital twin promise? What can I do perhaps as a manager of these spaces? Like,
Yeah.
what's going to be unlocked?
So globally speaking, a digital twin is a virtual replica of an existing facility that you can use for all kind of simulations. For example, when a car manufacturer needs to change his production chain, he needs to simulate that before he does the actual job. Could be used for even, we're talking to customers that want to teleoperate their sites using a digital twin. Okay. The difficulty that they are facing today is that getting a digital twin of an existing virtual replica of an existing place is complex. So you use laser scanning again to do that, because this is the difference between what we call a brownfield situation and a greenfield situation. Brownfield, you have an actual facility existing that runs, and greenfield is when you have a white sheet of paper and you build from scratch, okay? In which case you have probably a very accurate BIM model. You don't need to laser scan displays. But when you have brownfield situations, as the ones that are of interest for Cintoo, because this is where you have customers that have facilities or sites that have been around for 50 years, 60 years. They don't have the beginning of a model of that. They probably have lost the drawings of these facilities. So how can you bring these existing facilities in a digital twin concept for all these new, use cases? You use laser scanning to do that, okay? And then you create a virtual copy. First, it's a point cloud based or mesh based in our case, okay? And then sometimes it's good enough. You don't need to model from the point cloud and from the mesh, because what you have in the mesh is already good enough. And also it takes a lot of money to get to a very accurate model of, let's say, a refinery, for example, full of. So some people believe my scan is my digital twin. Fine. Okay. Some people say, no, I still need to have a scan to BIM process. So I need to create a BIM model from the scan. And then once I have the BIM model, I have my digital twin. So it depends what you are talking to. But so in a few years from now, every Fortune 500 has a complete virtual replica of every single, all of their facilities. We're talking to customers that have 50, 100 facilities. They don't know what they have inside, They very difficult to make asset management, very difficult to do predictive maintenance when you don't know the existing conditions, you see? So this is all the use cases we're embracing with Cintoo.
You're echoing a lot of what I hear as well. So in lieu of not having a digital twin, what are some of these sophisticated organizations using? Are we still on spreadsheets or CAD or photos? Like how?
Yeah, they go on site, they take notes, they take a tape measurement tool when they need to check clearances. They do it by hand. Okay, so no guy, an eye, also a person needs to go on site, need to travel to do all this kind of analysis. People are still doing that. When they need to run their asset management, they go on site, they take notes, they go all around. Now, after you use laser scanning, we use laser scanner, so we have laser scan data. We can run an AI engine to detect those equipment automatically. So we can already classify and geolocate every equipment you have in your facility. Okay, so you see between the difference between having a person doing that by hand, or sometimes it's multiple people doing that by hand to know which asset has which, maintenance log or whatever. Now everything is being digitized. And though once we know which equipment is located where, then you can connect that to your SAP or ERP system. You can connect that to your IoT sensor info, etc. So it's a completely connected, digitized environment that we are looking at.
In your perspective, is cost still the reason why all buildings don't have this? I mean, you're outlining a future that is everyone can agree that's what we all want, that level of clarity. Is it cost? What's keeping us from getting there today?
Yeah, so lack of knowledge and cost, of course. As I said at the beginning, the cost of scanning a place is getting cheaper and easier to do, but still it costs something. And for example, we have a customer in France. They are digital twinning all their substations in the territory. There are more than 3,000 of them. Each substation can be laser scanned with about 2 hours. But still, you have to laser scan 3,000 substation. It's a budget, okay? It's money. So you need to have a budget for that. And then the data is being hosted in Cintoo. This is a cheap part of it. Anyway, and then, running those AI classification, connecting that to your SAP data. This is still not completely automated. So cost is an issue, to be honest, okay? But the return on investment should be much higher. But all this is being, I'll say, we are still in the very early stages of this whole process, or this whole concept. So we are automating, through AI, through a lot of stuff. But still, there is no magic press button who say, okay, this is my scan. I press a button and this is my digital twin connected to SAP. No, that doesn't exist yet. And this is what we're aiming at. And that will take a few years, but this is, so I'd say cost, and I'd say there's a lack of knowledge as well. So people are not aware this is possible. Okay? So companies like yours, like mine, we are still evangelizing a lot around those concepts. Okay.
Yeah.
And this is also the fun part.
I want to hear your perspective to maybe change hats a little bit. You have a long track record of taking emerging technology, packaging it, and making it accessible for others. There's an art to that, right? It's very easy. I'm sure you and I engage with some incredibly smart folks in the academia space, really looking into this technology deeper. But there is an art to understanding how to connect this to the market. In your view, what have you learned in the last 25 years taking emerging technology and bringing it to market? Like what do folks miss? Like what do you get right about packaging technology in ways that people can actually understand. And I don't know. Right. Tell me.
Yeah, no, that's a very interesting question. I've learned so much talking to these scientists and PhDs, and there are a few lessons learned. Of course, what you need is not a piece of technology that works. It needs to be productized. Does it work in all cases? Not on the cases that you have tested in your lab, but industrial cases, repetitively, etc. So on this, sometimes there is a big gap here between a PhD that is very happy with this piece of technology. This works. Okay, but now let's try it on a refinery. Okay, not on this small room that you see. So productization is a big effort, making sure that it works in a lot of cases, industrial cases, and with a good repetitivity and all that. So I've been going through all of that. The first thing you would notice when you speak to a PhD that is still in the lab is this, this is a big, is the auto, I don't know how to say that in English, but auto persuasion. So he's persuaded himself that he has the best technology on earth. Okay. And sometimes, you forget to open your vision to the outside world. And what we say in the Silicon Valley is that when you have a good technology, probably there are 5 other technologies around doing the same thing. And when the technology is really good, there are probably 10 other technologies that are as good. You see what I mean? So sometimes the auto persuasion, do you say that in English, is very difficult. You have to fight against that, okay? Because this will take you to the wall. If you self-convince yourself this is the best technology, there is nobody else capable of doing that. Okay. And this is why I really love talking to them, but also I take the leadership on the product aspect of it. So, okay, so the product management aspect of taking this technology, making it work for your customers in a good way, adding all the features needed around. This is really what I've been doing over the last 25 years, and I love it. But again, be careful with the PhDs tell you, oh, this is unique. Nobody else is doing that. Okay, are you sure of that? And making it work in many different cases that the one you have been testing in your lab. You see, this is fascinating. I have been always fascinated, amazed by the way these guys handle mathematics on the computer. Oh my God, I am an engineer myself. I know mathematics, but not to this level. And so this is really a fantastic. I'm blown away every day by those guys.
And to your credit, your team and yourself have had a level of success where now Cintoo is not one of the emerging, but one of the very quickly expanding companies. You recently raised a Series B, if I understand, and to even get to a milestone like that suggests that there is clear adoption, clear traction, a clear understanding of selling to the market. For young entrepreneurs following in your footsteps, prop tech, con tech, any advice in the company building aspect? You talked about the technology, the productization. I ask because I often am approached by entrepreneurs myself, and I see that there's this gravitation towards I have an idea, I'll go raise money, and it's almost seen as like that is the only option. In your case, you spent years building this thing and had to kind of validate in every step along the way. What have you learned? Like, what if you could give yourself advice, young Dominique, before going venture, what would you tell yourself?
I will attend a product management. I can tell you, I'm very grateful to Autodesk. When I joined Autodesk, I sold my company to Autodesk, and then I joined the headquarters in San Francisco. The first month, they offered me this course in the Silicon Valley. What is a good product manager? And this is a big difference. Of course, I was doing some kind of product management to get my company to where it was when I sold it. But if I had this mindset from the beginning, as a product manager is a person that understands his business. He understands the problems to be solved, and he is good enough with the technology to tell the developers what to do. And he has also a business mindset to say, okay, if we solve this problem, I'm sure we can sell it by that much. Okay, so it's kind of mixed mindset between technology, you know, understanding the market, and also having a business mindset. Okay, this is, at the end of the day, this must generate revenue. Okay. And definitely the first advice I've been always giving to some entrepreneurs is always, okay, if you are not yourself a good product manager, make sure you have a good one in your company. Okay. And it makes a big difference. I would say this is, then of course it's about solving real problems that people are willing to pay for. It's also understanding the big difference between a nice to have feature and a must have feature, because, people would buy the must have. They would probably do a POC or POC with a nice to have, but you will never deploy that. Okay. So make sure your technology, your product has a potential to become a must have. So this kind of concepts, are really, really key. And then, of course, you must be on a business that can scale. If you're serving your local community, okay, that's fine, but is it scalable? And of course, now if you want to raise money, you have to find a recurring business model. The key here is now ARR, annualized recurring revenue. This is the main, if you have, but you know that we have been discussing this one already. But so having a business that is a recurring business will attract much more investors than any other service business.
In your experience selling, what is your view on selling specifically? We spoke about industry, right, or industry 4.0. We spoke a little bit about, the kind of laser scanning and AEC space. I certainly can imagine is different than selling social media and metaverse experiences. So what is there something you've learned about selling into AEC and industry that's specific to the sector?
Yeah, I always have been in the B2B situation. I would not be able to run a company that is in the B2B or C2C, selling millions of stuff, a small amount. I'm not this guy. Okay. There are certainly much, much better entrepreneurs for doing that. So it's more about selling. What I have been selling all my life is high-end technology that costs a lot and that people are really happy to pay for. So it's really a B2B. Selling B2B is very different than, selling B2C, or I would not be able to run a social media company or, advertising company or anything like that, And so selling B2B is, yes, you have to find the right sales guys, direct sales in most cases. So you have to go to trade shows. You have to find the right network of partners. And this is something I know about. Okay, you see what I mean? But so my expertise is in the B2B business. So, but again, I'm not the best sales guy in the world either. I mean, so I've been lucky enough in 2019 to have my colleague Rob join me, also coming from Autodesk, to take the lead on the selling. And that was perfect. Okay, so we kind of, at some point you have to know what you're good at. So again, my expertise is around strategy, product management, understanding the customer requirements, turning that into specifications for the development team, talking to partners. But running a sales team, now there are better people than me to do that. You see what I mean? So I'm lucky now that since we raised a Series B, to have a very strong team with CFO, CMO, CSO, CISO, CTO. We are really a strong team now, and this is making my life much easier, of course.
It wouldn't be a technology podcast if I didn't bring up AI. So I'm curious. I think it's on all of our minds, and we're, I'm sure, both playing around as well as deploying some of this in our own operations. Do you find that there's a difference today in the way that we build companies, we grow, than say even 5 or 10 years ago without it? I mean, how are you thinking about deploying it across your organization?
That's a very good question. By the way, we are having an internal workshop around AI in the next few days. There are two aspects. I would say AI as a tool that you can use internally to increase your productivity. Developers are using AI every day now. Okay, marketing guys are using AI every day. So I would say Cintoo is already an AI powered company. What we need to do now is organize this better because everybody is using different tools. This is not coordinated. And since we're ISO 27001 company, we need to put some coordination around that, okay? But otherwise, they are already using AI. So for developing faster, better, the point is that, and I was talking about that to my colleague Edwin, our CMO, say, don't trust AI all the time. At some point, there is a tendency to say, okay, AI said that, so it must be true. Okay, is that like 10 years ago or 20 years ago, say, oh, Google said it, so it must be true. No, still you have your own stuff, okay? So that's point number one. AI as a tool, we already use that. Most of the companies are using that. Cintoo is one of those software developers that is using AI a lot. But still, we need to keep the control, make sure we use AI properly. Now we also have the other way, which is AI as a feature. How can we put more AI in the product to increase the value of the platform, and of course, make our customers more successful and eventually sell this capability. So we have already embraced AI since 4 years, 5 years now. We started our own AI engine to automatically detect equipment and geolocate and classify equipment in the scan data. And this is a work that took us for almost 5 years, yes. So this is purely machine learning, okay? So by using machine learning, you teach your machine learning engine to look for certain equipment. You do that by hand first, 500 times, 1,000 times, and then you have enough data to have an automatic process, okay, that will enrich by itself, And the list of classes we can detect, the list of equipment that we can detect, I think we can detect almost 50 classes of equipment now, but there's more. With AI as a feature, we can certainly apply AI for, semantic search, for, giving guidelines to our users. We can also use generative AI to complete 3D models that are not complete. Whatever, there are many use cases where AI will apply. Yes, this is a tendency. You cannot not use AI today. Anyway, I'm sure that any software developer is using AI, even if they don't tell you the truth. They are already using AI, that's for sure.
We've talked quite a bit about, the last 25, 30 years of evolution from photogrammetry to LiDAR to meshes to BIM to AI. And the pace at which this comes is it feels like every day, every week, that there's something you have to keep up. In this environment where everything changes on a day-to-day, I like to kind of end by asking, in your view, in 10 years from now, what is likely not going to change about the way that we engage with buildings? We've talked about our ability to detect things, scan things, turn things from scans to meshes. What doesn't change in 10 years from now with the way that we engage with buildings?
That's a great question. I should have prepared this one. There are so many different tendencies in the way we build buildings now. But I'll say what will not change. I don't know what to answer to this one. This is a tough one. Let me think about it.
Maybe that's the case. Maybe it's just the only, what is it, the saying, the only constant is change itself. So
no. But still, for me, we're at the very beginning of all these new technologies. When you look at of course, when you do some Series B funding, you have to go through market analysis and see, okay, how much of the business. And when you look at all the market research for all these guys or Gartners and things like that, we're just at the very beginning of digital twin. It should be like that high in 10 years from now, okay? They also said that for virtual reality 20 years ago. So we don't know exactly where but anyway, for me, we have just scratched the surface of the potential. And we are just addressing the most progressive firms. But there are all the other firms that are not yet there, that didn't even start thinking about laser scanning, So in 10 years, we will still looking for these companies, where are you and why don't you apply these technologies? At least in the industry 4.0, we are in the oil and gas, where energy distribution, car manufacturing, they don't change that fast. The pace of changing is going smoothly but surely, because these are so critical, industries. In the construction building, it's the same. And they embrace drone flights. They embrace laser scanning. Now we are getting to a more automated progress monitoring, so detecting differences between what has been built versus the BIM model that is the reference, the intent of the designer. So we are getting to a more automated world, but still people will need to build buildings on they will need to bring crew on site, and they will need to laser scan to make sure that what has been built is according to the design intent. So 10 years is so close,
Yeah, yeah. Well,
only 50 years I will be dead. So anyway, I don't.
well, you're paving the way for the future. That's for sure. Dom, it's been really fun, and I trust for those listening, it's been incredibly fun. I'm grateful. It's a Thursday. The last thing you probably is on your mind is doing a podcast, but I know that this is gonna bear fruit for a lot of the folks listening. So
That was a real pleasure. Thank you for this opportunity.